Alright, let's look at the log rule and the general log rule, alright, for integral. Alright, so we know how to take the derivative of natural log, right? So if you have a natural log of x, and if you take the derivative of this, you're going to get 1 over x, right? But one thing you need to be a little bit careful is that there's another function whose derivative is exactly the same thing. So, which is natural log of negative x. Alright, so if you take the derivative of this, what you're going to get is, first you have a 1 over negative x, but because of the chain rule, you have to multiply by derivative of the inside. Derivative of negative x would be negative 1. Right, so which means that negative signs cancel out. So you end up with exactly the same positive 1 over x. Right, so if you take the antiderivative of 1 over x, you're going to get one of these things. But we don't want to have two separate formulas, so what they decided to do is, why don't we combine these two guys, right? So only difference is there's a negative sign in front of x. So what you can do is you can just say, all right, so this is going to be a natural log of absolute value of x, so we don't have to worry about the negative sign, right? So then we take the derivative of that. Alright, so therefore, if you take the antiderivative of 1 over x, you're going to get natural log of, alright, don't forget this, absolute value of x, alright, plus some constant c. Alright, and the same way, we can generalize this a little bit. If you look at the, say, natural log of g of x, right? Then if you take the derivative of this, you're going to get 1 over g of x, but you have to multiply by derivative of inside, so g prime of x by chain rule. So if you want, you can write it as g prime of x over g of x. All right, and we can do a very similar one. Maybe I should use a different brackets here. Whoops. I'm going to erase this here. Going to erase this there. And I'm going to put the curly bracket so that I don't get confused with the square bracket that I already used there. Alright, so if you have a natural log of negative g of x, and then if you take the derivative, you're going to get 1 over negative g of x multiplied by derivative of negative g of x is negative g prime of x. And as before, we can cancel negative sign on the bottom, negative sign on top. You get exactly the same thing, g prime of x over g of x. Alright, so again, we don't want to write two different formulas, so to write it in one shot, you say natural log of absolute value of g of x. Right? That way, we don't have to worry about the negative sign. Alright, so therefore, antiderivative is natural log of absolute value of g of x, and then plus some constant c. Alright, so let's look at a couple of examples. Alright, first one, we have to do a little bit of rewriting. Alright, so I'm going to split into smaller fraction here. So you have a 2x divided by x squared. Alright, so first thing is you can pull 2 outside, so I'm going to pull 2 out. Right? Then one of the x cancel out, so it's going to be just a 1 over x. Right? Then the other one is just a 1 over x squared. So it's just a reciprocal of x squared, which is the same thing as x to the negative 2 power. Right? Then we just have to find the antiderivative. Right? So 2 is a constant multiple, so we put 2. Antiderivative 1 over x is natural log of absolute value of x, as we just learned. And the antiderivative of this is going to be add 1 to the power. So you have x to the negative 2 plus 1, so it's negative 1. All right, divide by negative 1 is same as multiply by negative 1. So I'm just going to put the negative sign. And then you have plus some constant c. Right? And if you want, you can rewrite it as a 2 natural log of absolute value of x minus e to the negative 1 is equivalent to 1 over x plus some constant c. Right? That's that. And how about the next one? Right? So we are trying to look for this pattern, g prime of x over g of x. Right? So let's take this guy right here. The denominator is going to be g of x. So what you really need on top is the derivative of g of x, which happens to be negative 3. Right? But we have 2 instead of negative 3, so we have to fix that. Right? So easy way to fix it is this. Right, first thing we can do is pull 2 outside. So pull 2 outside. Right, then you have denominator stays the same, 5 minus 3x. Right, so what we want is negative 3 on top. Right, so what you can do is you can actually put negative 3 on top. But this way, we're multiplying by negative 3, so we're changing the quantity. So we're going to have to divide by negative 3. So that way they cancel out. All right, then with respect to x. All right, so you have negative 2 over 3 is just a constant. Right here, we have a g prime of x over g of x. So you have a natural log of absolute value of 5 minus 3x, just following the general log rule. And then you have plus some constant c. Right? That's it. I hope that this was clear.